Hi everyone, this is Mr. Chen, and because I got a fever, so I will be absent tomorrow. Okay, that is today to you. All right, so I make this second video to you. Okay, hopefully we can catch up with the schedule. Okay, because we are far behind. All right, so let's start. Okay, yesterday I introduced you the concept of differentiation. Okay, we find a derivative of a function y equal to fx by using first principle. Okay, and for any y equal to fx, for any function y equal to fx, its derivative, okay, can be denoted by these two notation, okay, dy over dx or f prime x. Okay, they both have the same meaning, which is the derivative of the function y equal to fx, will be given by limit delta x tends to 0, fx plus delta x, alright, minus fx and over delta x. Okay, so if you do not do any simplification, then you will see this limit should not exist because it becomes 0 over 0. Alright, but we all know, okay, we need to use our skills, okay, to simplify the function here so that we can check whether the limit exists or not. Alright, so yesterday I showed you how to use first principle to solve functions like y equal to x squared, y equal to x power to 3. Okay, and I asked you to do some practice on your own yesterday. Okay, even number from question, I don't remember, 1 to 15, something like that. Okay, if you have not finished it, use this double lessons to finish it. Okay, but before that, I want to give you one example. Okay, I want to focus on the using first principle to find the derivative of trigo function. Okay, that means sine, cosine, or tangents. Okay, those are some trigonometric functions. Okay, the scale will be very different as this one, as the original one I taught you yesterday. So let's start. For example, if I ask you to find the derivative of y equals to sine x, okay, that means fx is sine x. Okay, so if I ask you to find the derivative by using first principle, how should you do it? So let's start. Solution. The dy over dx equals to limit delta x tends to 0 and sine bracket x plus delta x minus sine x, and lastly over delta x. Okay, so it will be very natural for us to try to use compound angle formula to handle this part. Okay, the compound angle formula, sine A plus B equals to sine A cosine B plus cosine A sine B. Alright, so we use it. X tends to 0. So sine x cosine delta x plus cosine x sine delta x minus sine x over delta x. Okay, so now look at our step here. Can we find any way to cross out delta x, okay, to make the whole thing exist? Okay, so I think the answer is no, okay, because there is no such a common factor delta x that we can cancel it. Alright, so we have to use other way to solve this problem. Okay, so it's very natural for you to try to factorize this to sine x. Okay, then we will just do it. Delta x tends to 0, sine x cosine delta x minus 1 plus cosine x sine delta x and over delta x. Okay, so now I have to tell you one very important concept here, okay, about limit. Now we're focusing on the limit of these fractions. When delta x tends to 0, that means the variable that I concern should be delta x, but not x. Alright, so this sine x can be ignored, okay, because nothing to do with him. Okay, none of his business. This cosine x as well, okay, because the variable delta x is not in these two components. Okay, so the only part we have to care about is cosine delta x minus 1 over delta x and sine delta x over delta x. Okay, these two parts are important. How about sine x and cosine x? None of the business, okay, because the variable delta x tends to 0 is a concern. Okay, how about x? Okay, we don't care. So let me clear it. The limit delta x tends to 0. Okay, now we can write the whole thing in this way. Okay, I want to split this fraction into two. Okay, so they share the same denominator, delta x plus. Okay, cosine x, actually none of his business, but okay, you should still keep it there. Sine delta x over delta x. Okay, so if I write the whole limit in this form, then hopefully you got the idea. Now you got the idea. Cosine x, sine delta x over delta x, this part. Okay, when limit delta x tends to 0, this will become 1. Okay, if you forgot, let me write you a note here. Limit theta tends to 0, sine theta over theta should be 1. Should be 1. Okay, so this is what we learned from the last chapter. So this limit tends to 1. Therefore, we don't have to worry about it. Okay, problem solved. So now the difficult part is this guy, cosine delta x minus 1 over delta x. Okay, so actually we have tried to solve this question somewhere before, okay, in chapter 3. Okay, but that time we don't have sine x, we don't have the other thing to make this question become trouble. Okay, so I'll just show you how to solve it. Okay, so now the problem is, does this exist? Does this exist? Limit delta x tends to 0, cosine delta x minus 1 over delta x. Does this thing exist? If it exists, then the whole thing, the whole limit before will be exist. Okay, so let's try to look at this. So I think the only way you thought of to tackle this problem is to multiply cosine delta x minus 1 by its conjugate. By its conjugate component, like this. Okay, that we always try to multiply it by its conjugate. Okay, actually, I don't remember who one of you gave me this very smart idea. Okay, so it will be cosine square delta x minus 1 over delta x and cosine delta x plus 1. Okay, so since 1 minus cosine square x will be converted to sine square x, then obviously cosine square delta x minus 1 will become negative sine square delta x. Okay, delta x tends to 0. Okay, I forgot the x here. Delta x tends to 0. So now over delta x, cosine delta x plus 1. Alright, so now this becomes our problem. And very obviously, limit delta x tends to 0. Okay, what you should do is to split this square into something like this. negative sine delta x over delta x, and another sine delta x, okay, because we got a sine square delta x here, another sine delta x over the last part of the denominator, cosine delta x plus 1. All right, so now does this limit exist or not? The first part will be 1, okay? I reminded you just a few seconds before. So now delta x tends to 0. Does it affect the second fraction? Okay, I don't think so, because sine delta x tends to 0. When delta x tends to 0, the cosine delta x tends to 1 when delta x tends to 0. Therefore, which means the whole thing becomes negative 1, 0 over 1 plus 1. That is, the limit should go to 0. Alright? Okay, and I want to directly apply these results to the previous part. Okay, now we know this limit sine delta x over delta x will be 1, but this limit cosine delta x minus 1 over delta x will be 0. Okay, so I can put the things like this: sine x times 0 plus cosine x times 1. Okay, actually at the beginning, none of the business. Okay, still remember, we are focusing on the variable delta x, so sine x isn't involved, cosine x also, okay, will not be involved into the limit. So sine x times 0 cancelled out, cosine x plus 1, the final answer should be cosine x. Okay, so this is the result. If I want you to use first principle to calculate, okay, the derivative of y equals sine x, then it should be cosine x. Okay, revise the skill. Okay, first we use compound angle formula, and then we transform the fraction into something like this. Okay, this part, sine theta over theta goes to 1. Cosine theta minus 1 over theta goes to 0. Okay, so I've showed you why. Okay, you should practice it. But I think most of you will find this method is very trouble. So I'll give you another alternative, which is far easier. Okay, but I think most books use this trouble method to solve the derivative. Okay, so I give you another alternative. Sorry. Alternative. All right. Now still y equal to sine x. Still dy dx equals to limit delta x tends to 0. Sine x plus delta x minus sine x over delta x. Okay, so the reason why the steps are very trouble and difficult before is because we use the compound angle formula to expand sine x plus delta x. Okay, but apart from that formula, we still got another one. Okay, concerning about sine a minus sine b. Okay, that is the sum to product formula equals to 2 cosine a plus b over 2 sine a minus b over 2. Okay, simply use this formula, you got the limit. Limit delta x tends to 0, 2 cosine x plus delta x plus another x, so altogether you should got 2x plus delta x over 2, and followed by sine x plus delta x minus x, so delta x over 2, and over the original delta x. Okay, now try to put delta x into the limit. Cosine 2x plus delta x over 2, delta x becomes 0, so it becomes cosine 2x over 2. That is cosine x only, so none of his business. This guy already exists if I put delta x tends to 0 in it. So now we have to consider this part, sine delta x over 2 over delta x. Okay, does it look very familiar? We have used this skill so many times in this video. Okay, should tends to 1. Okay, but you have to do some checks. That is, make this delta x become delta x over 2, make this delta x become delta x over 2, then simply, okay, put over 2 on it. Sorry. Okay, simply put delta x over 2 on it. But how to counterbalance this over 2, the action of this over 2? You should multiply 2 right before it, so that the whole thing become balanced. Okay, balancing equation, very easy to you guys. Okay, so now that means the limit becomes delta x tends to 0 to cosine 2x plus delta x over 2 over another 2. So this is the first part of the fraction, times sine delta x over 2 over delta x over 2. Okay, I simply split this fraction into 2. Then obviously the limit goes to, the last part will goes to 1. How about the first part? It becomes 2 cosine 2x over 2 over 2. So obviously cosine x. Okay, that's it. So you can try to compare this two methods. So I think obviously this one is far more easier. Okay, so this gives you a hint whenever you need to find the derivative of a trigo function by using first principle. You should always try to use the product to sum or sum to product formula before you try to use compound angle formula to tackle the first part. Okay, yes, using compound angle formula seems more natural to you, okay, because you think of you can expand the whole thing and simplify it, but actually the step to simplify is very trouble. Okay, so my advice is to use this one rather than that one. Okay, so now for the rest of time, use your time to drill chapter 4a, exercise 4a. Okay, level 2 questions. If you haven't finished level 1 yet, do it. And okay, let's focus on even number only. Okay, we don't have time to finish them all, so please finish even number of exercise 4a. All right, and also if you still got time, try to find the derivative of y equals to cosine x. Okay, the step will be very similar to what I have shown you in this video. Okay, so please use your time, do revision. Okay, remember this formula. Okay, so hope I can see you next day. All right, goodbye.